I'm going to introduce Joe DeLeo. Joe is a co-founder of the Weather Channel in 1982. He was responsible for hiring and firing and directing the initial staff. He's a certified consultant meteorologist. That's what the CCM stands for. It took me a long time to remember what that meant. He established a very successful program at Linden State College in Vermont. He's also the department chair. He's a partner in WSI Corporation, but he focused on product development, especially including modeling for climate attribution, a key issue. He's authored a resource guide on El Nino and La Nina. He's been active with me and others in terms of the EPA embankment finding. A lot of his science is actually on file before EPA and in lawsuits. So he's been there. He joined with Joe Bastardi to co-found the Weather Bell Analytics. So he's a co-chief meteorologist there. He's chaired the AMS Committee on Weather Forecasting and Analytics. He was the first private sector meteorologist elected by his peers as a counselor for the AMS. And then the AMS has gone rogue on us, I guess. But he graduated from the University of Wisconsin with both a BS and MS meteorology. He is AVD in atmospheric chemistry at NYU. He's been awarded an honorary PhD for starting one of America's foremost programs at a university. Joe, you're on. Thank you.
One of the commonalities of all the models and the greenhouse models is what we call the tropical hotspot that is found in the upper atmosphere in the tropics. And it's in an area where the trade winds come together and the air rises and thunderstorms form and release sensible latent heat. And that's where the greenhouse models say that carbon dioxide and water vapor trap the heat. So let's see if that really does take place. If you look at an average of temperatures in that hotspot region for a number of the models, going back to 1979, it's as flat as can be. So there's, yes, the warming is taking place where there is convection in the tropics, but it's not accumulating. It's not being trapped there. And you can see in the ocean too, beneath, you would expect the oceans to be warming there. And yes, they warm and cool with El Ninos and La Ninas, but when you look at the full transit across the Pacific, there's no trend since 1979. Now, the models you see are failing miserably. They overstate the warming in this tropical area by a factor of 3. And you can see that compared to balloon, satellite, and US reanalysis data. There's one model that gets it right, the Russian, but they downplay greenhouse, and they also include solar. The other models don't do much with that. Okay. John Christie shows this slide that shows what the greenhouse model does in the tropics. Greenhouse models in red shows that tremendous warming that takes place up between 25 and 50,000 feet. If you take the greenhouse effect out of the models, the blue curves apply. And what's the reality? The reality is the gray areas. And that falls entirely within the non-greenhouse models. And the greenhouse models are much too warm. Okay. So one of the things that most people think is that we've been tracking temperatures since the 1800s. No, we haven't. Would you believe we didn't start doing temperature trends on a regular basis until 1989 to 1992? In fact, the first attempt to look at trends and look at data was done by the National Academy back in around 1970, early 70s. And they found a 2-degree warming from the 1880s to 1940, and then a cooling that was 1 degree, and it continued into the late 70s, almost completely reversing that that original warming. The area why they focused on the northern hemisphere is, you can see there's virtually no data in the southern hemisphere, certainly not in the oceans, and the land masses were mainly the United States and Europe with data. And this is what the data showed. Hansen talked about this. This is the first U.S. data set. U.S. had the best data, right? So Tom Carl pulled together the data from the stations, 1,200 stations since 1980, and it showed a sine wave type of warming, change, with warming peaking around the late 30s to around 1940, a cooling like we saw, and then a warming again. But Hansen said, when asked about why the warming was not as great in the United States data, that we were only 2% of the world, and really the rest of the world was warming. But in the New York Times in 1989, when Carl's first data set came out, said the US data fails to show warming trend. And one of the things that Tom Carl did right when he did that is he included the urban heat island. He adjusted the stations that were city. Now, I used to teach this in my climate courses, my microclimate courses, because the cities are warmer than the suburbs. They hold the heat at night, at least. During the day, it's pretty uniform. But here's London at the bottom. It can be 5 degrees Celsius, or 9 or 10 degrees Fahrenheit warmer at night in the city than in the suburban areas. And even the EPA admits that. And Edward Long of NASA showed in 2010, he compared the rural data with the urban data, and you see the trend, the warming in recent decades has been mainly in the urban data, a slight warming in the rural areas, but that sine wave existed. Now, when I look back at the original data and carried it over to about 2010 and looked at it compared to CO2, they both went in the same direction. They were positively correlated 40% of the time. Now, if you're successful 40% of the time in baseball as a hitter, right? You bat 400, you go to the Hall of Fame. In weather, climate, and economic forecasting or commodity trading, you got to find another job. So what did NOAA do? NOAA removed the urban heat island adjustment and made a change to the data. And this is an animation that Tony Heller shows. And suddenly 2000 became warmer than the 1930 peak. And my friend Tom Weissmuller up in Maine, I did a presentation up there in 2011, downloaded this data. This is the Maine temperature data from NOAA and NCEP. And you see there was no trend in Maine in 2011 when I did it. Actually, it was minus 0.01 per decade degrees Fahrenheit. When I went back to do a reprise of that presentation and downloaded the data 2 years later, they had cooled off the past, and the trend had increased to 2.3 degrees Fahrenheit per century, the highest in the country. And the Portland Press Herald did a story, Maine's warming faster than any other state in the country. Global warming is real. Instead of adjusting the models to fit the data, they adjust the data to fit their models. And by the way, that cycle that they showed originally fits nicely to the ocean cycles and the solar cycles in my attribution research over the years. Okay, global temperatures. We focused on US data. This is the number of stations that are used in the database going back to 1820. Well, even in 1880, there were only 26 stations in the data. We're 23,000 right now. So not a lot of data to compare. And this is what we're showing here. Not a lot of data in the in the long-term temperature record. Now, short-term, it's different, but long-term, going back in time to determine long-term trends. When Hansen NOAA got together, and Hadley and started making the changes to make the data fit the models, instead of trying to figure out why their models were so wrong. And you see what they did is, in the adjustments, each revision pushed the old data down further and further to increase the warming. And they increased the warming as they allowed urban heat to run wild in more recent times. So remember that 2-degree rise and the 2-degree fall that they determined by the National Academy in 1970s? It's gone, basically. It's flat. There's no warming trend. And look at, even in areas where they had data, they took the data and adjusted it. This is Reykjavik in Iceland, showing the warmth of 1940 and the ice melting, and then the cooling. See what they did? They cooled off the past. And even though the ice was melting, they had it cold in that time period. When the Iceland Weather Service was asked which is their real data, they said, well, the one on the left is our data, that's what we use. Stations are also an issue. Look at the, this is a map of the number of missing months by continent, by continent. You see, as much as 80 or 90% of the stations are missing months. Even North America, North and Central America, it's as much as 50% now. The bottom right is an example from Asia of stations, of a station, and the red are missing months. How do you get an average annual temperature when you're missing 3, 4, 5 months, right? It's a little bit like trying to figure out who won a ball game when you know only what happened in the 3rd, 4th, and 7th inning, right? Good luck getting it right. And here's an example. Tony Heller shows this for 2018 September. The actual data they start with is on the top, and there's no data over the Middle East, and that's before they add the ocean in. But a lot of the continents are missing data. When they put their models or algorithms to work to fill in the holes, look what happens at the bottom. It's red everywhere. And in fact, it's record hot in areas where they had no data to begin with. Now, the globe is 71% ocean. And we've changed from measuring with buckets to ship intakes, to water's taken in to cool the engine. There's thermometers in that. Satellite after the 1970s. And then finally, in 2000, the Argo buoys were employed. And you see the full global coverage for the first time. Well, at this, in about the same time, we went into a pause after 1997 that lasted till 2013. And for a while they ignored it, but then they had to say something. So even Kevin Trenberth acknowledged it, did a paper about it, and said, well, the El Nino and ocean cycles can have an effect on a short to medium term. And the AMS in 2015 had 3 panels to address it, but they made it go away in 2015. They made the pause go away. Wigley had suggested in one of the ClimateGate emails that, you know, the oceans have an opportunity. We could adjust it by 0.15 degrees Celsius. Nobody would know it and would agree better with our models. So in 2015, just before the Paris Climate Accord was to be signed, John Bates, a former data quality who retired, said Tom Carl took good data from the buoys, and those buoys were designed to accurately measure temperature and heat content in the ocean, and adjusted it for the ship intake. They had to find a reason to get the pause to end. And so they adjusted all those Argo buoys, and you can see what happened. This is Holly Humlum's Climate for You at the bottom. The raw Argo was showing up and down with El Ninos and La Ninas, and then the adjusted data shows a resumption of the warming. Okay, let's get to the extremes, because this is all a predicate to, it's supposed to be this global warming is kicking off all this bad, weather for affecting people. Heat waves, for example, is supposedly rising. Well, when you look at the state record highs, the big decade was the 1930s, 22. 37 of the record highs were set before 1960s. The last 2 decades have been benign, or in terms of effect, in terms of records. John Christie shows this. This is the record high temperatures for 804 stations that have 100 years of record. You can see the trend is down, not up. The 10 top years were all before 1955. 90-degree days have gone down. 105-degree days have declined. Even the EPA's heat wave index shows the mountain was back in the 1930s. Well, NOAA had to finesse that. The reason they can't adjust their heat records is everybody's got it. Every TV station's got heat records for the date, okay? If they went around and changed all the past records, people would say, now what's going on here? So they didn't. They came up with a new trick. They created a ratio of record highs to record lows. Now, both are decreasing, but because of urban heat island, record lows are decreasing faster. So when you do the ratio, it makes it look like we're warming up. And all we're doing is not warming up during the day, but we're warming up at night. There's fewer records. Globally, look at the old temperature heat records were set in earlier decades. And Tom Peterson, who ran the U.S. data set, went over to the WMO in about the time when Obama left office, and he became part of the extremes committee over there. And he's making this go away. He's he's found a temperature at the tip of the Antarctic Peninsula that has a new record high, and he's found 1 or 2 in Arabia that may have just beat out that 129. He's going to do his best to, confirm the theory. In terms of tornadoes, the trend is down. Now, 55.9 per year from 54 to 1985, it dropped to 33.8 after that. Now, it actually is counterintuitive, but it's during colder eras that you get more tornadoes, Tom will tell you. And in warm periods, less tornadoes. And the actual spikes that you see in recent years, like 2008 and 11 and 1999, were during the La Nina years, which were years with contrast. And it's contrast that produces it. You see, Storm Prediction Center shows it right when you have La Ninas and you have cold air in the central part of the country, you have this contrast zone. On the right, you get above normal number of tornadoes. On the left, when you have El Ninos and the contrast is weak, you have below normal tornadoes. A good example of that, look at May of 2018. Warm everywhere, right? If heat was causing tornadoes, you'd expect that to be a very active month. But really, it was one of the quietest Mays on record. The next year, we had a record high number of tornadoes, but we had extreme cold in the central and warmth in the southeast. That contrast zone caused the tornadoes. Hurricanes, the ACE index, the Accumulated Cyclone Energy Index globally, and for the Northern Hemisphere, is up and down based on ocean temperatures, but no real trend up. The ACE index for the Atlantic shows these spikes, and you can see cycles in there. We'll explain those in a minute, but there's no runaway warm increase in that data. The peak years for hurricanes in 1933, 2005, 1893, 2004, and 17 made the list too. But you see, back in, we said 93 was the top year, 2005 was very similar, very close. But back before satellites, we had no idea what was happening in the Eastern Ocean, right? Unless the ship happened to pass by. And there are a lot of storms you can see in 2005 that could have happened also in 1933, so it could have been even more intense. Ocean temperature does play a role in in action in the Atlantic. You can see the number of tornadoes of hurricanes in red on the top left, and you see the Atlantic temperature cycles. It models well to that, and also the ones that make landfall in the eastern United States tracks well with the warm years. In Texas, the trend has been down decade to decade. In terms of major hurricanes and hurricane landfalls. In 2004 and 5, you see at the bottom for landfalling major U.S. hurricanes, we had those 2 big years, and including Katrina and Rita and Wilma and Charlie. But they said this is the new norm. But then we went into a 12-year period where we had no major hurricanes make landfall. This is the trend of hurricanes by decade and major hurricanes making landfalls. And this is the most accurate data set because we don't have to worry about what happens in the eastern Atlantic here. These are the ones that actually came ashore. We have good enough data to establish this reliably. The trend is down. This last decade, the 2010s, were the second quietest decade going back to 1850 for both hurricanes and major hurricanes. Now, this year we have a lot of hurricanes, and everybody said, oh, this must be due to global warming. We asked the number of hurricanes and tropical named storms is 23 now, which is high. The highest was 28 in 2005. But you notice on the right, the ACE index is not remarkable. It's much lower. These storms were mostly short-lived. There's only one major. Yes, we're a little bit above normal, 131% for the ACE for the North Atlantic. But it was well over 250% in 1933 and 2005. The Pacific has been very quiet. The Indian Ocean looks high, but they only get, on average, 1 or 2 storms a year. They had 2 this year. 1 was a major. But you see the Northern Hemisphere is only 64.9%. So really not a remarkable year for hurricanes. Now, droughts and floods. This is a long-term trend. NOAA admits there's no real trend in it. You get some dry years and wet years. 2019, we had a record small area coverage of drought at one point. This year, we have a much larger area of drought, but there's been no real trend in that. Now, we get floods when we get big storms, of course, certainly, hurricanes can contribute a lot to that. You in the Houston area know that. From Harvey in 2017, you have 171 rain gauges to make sure you don't miss anything in Harris County. Most of the storm records for the United States for rainfall in an event occurred in Texas and the rest in the South. And why is that? Well, the hurricanes develop in the Atlantic and Caribbean. They move west, and they want to turn north at first opportunity. And if they're not given that chance by high pressure, they'll move inland, and then they might sit for days like Harvey did, and some of these other storms that sat. You see 6 of the 10, actually, if you add Florence, it's 6 out of 11 were Texas events that produced the most rainfall. But it can happen in non-hurricane. In 1935, a massive flood had the water level 15 feet higher than during Harvey, believe it or not. So it's an area that is vulnerable to that. Wildfires, an annual thing in the West. We see in terms of the number of fires this year and acres burned, it's significant, but there's no real trend. We're not the top year. We used to have a real fire problem before livestock grazing and fire suppression and Smokey Bear. You can prevent forest fires, and it declined. But in recent years, it's bounced back some, and a lot of this has to do with bad environmental policies. They have a great disdain for foresters, for ranchers, farmers, fishermen. They don't want the farmers to have the water, and they want to keep the foresters out of the forest. And the radical environmentalists actions are creating a nightmare for the West. In the U.S. Forest Service said they had 129 million dead trees on 8.9 million acres. They have a tree mortality task force, only removed 1 million dead trees. So this is the tinder for the fires. They passed a bill in California to have PG&E go into the forest, remove the brush and the trees, and create fire breaks, but remove them near the where we had power lines. But it was vetoed by Governor Brown, and they had the forest, the fires that damaged that followed very soon thereafter. The logging industry is in free fall. Harvesting's dropped by 80% in 40 years, and the national forests action is being delayed or killed by frivolous litigation. They'd rather see forests and communities burn than see a logger in the woods, according to the Interior Secretary Zinke, a recent one. The other reason why we're having problems is people are escaping the city, right? They're going up into it's so beautiful up there in the mountains with all those beautiful trees. They're building homes, and gee, we need power for our homes, right? And you got power lines everywhere, and it creates more problems. Okay, another thing, they're telling us that snowfall is going because of, and the ski industry is going to die because of global warming. Is that really happening? Well, look at the Northern Hemisphere snow extent since '67. Does that look like it's declining to you? This is Northern Hemisphere, but if I did the North America one, it's even more severely upward. And most of the big years have been recent years. And winter is the same story. Most of the big winter years have been since 2002 and 3 for snow extent. The number of major impact winter storms along the East Coast the last decade, ending in 1819, was 29. No other decade had more than 10. Where these snowstorms are supposed to be disappearing? Look at the 10-year running mean of snowfall in Boston and New York City. It never was higher than it was ending a few years back. Now they had a lean year last year, and it started to decline. You can't go up forever. What goes up must come down. But it is higher, not lower. This was my street back in 2015. You may see my wife behind the wheel of my snowplow in my driveway there. We had a big snow year in New England. Let's move to the Arctic. We've had some lean years in recent years, 2007, 8, and 12, and 2020. It's supposed to be gone by now, but it's not. It's about the same. So what's happening in the Arctic? Well, the Arctic ice is floating, as Tom said, right? So the water from both oceans can flow underneath the ice, and does. There are currents underneath the ice. And if the water happens to be in the Atlantic and it's warm mode, there's warm water flowing underneath the ice to melt the ice. And the same thing in the North Pacific. And so there's more melting and slower ice freezing in those years. This was actually done by the International Arctic Research Center in the University of Fairbanks. And top shows the water temperature cycle. We talked about cycles in the ocean and the Atlantic for hurricanes. Remember, it was warm in the 30s and 40s. When the ocean is warm on the top, the ice is in the middle. You see, the ice is less than the normal, right? Makes sense, right? Warm water goes under the ice, thins it. When it gets cold, the ice gets, stays longer, builds faster, and is greater, as we saw in the 60s and 70s. And then we've had the recent Atlantic warming that caused the ice to diminish. And temperature follows the ice. So the Arctic is warmer as the ice is less, as the warmer water comes in from the Atlantic. And the same thing happens in the Pacific side. National Snow and Ice Data Center sometimes would get a statement out of a government agency that actually tells the truth. They said, one prominent researcher at the University of Fairbanks points out that pulses of unusually warm water have been entering the Arctic from the Atlantic, which several years later are seen north of Siberia. They help to heat the Arctic Ocean, contributing to summer ice melt and reducing the ice growth subsequent to that. Now, Rutgers' Jennifer Francis did research that showed the same thing, but she blamed that warming in the Atlantic on global warming. But she got that right. Now, the NSIDC continued. They said in Japan, the scientists are saying that the water can enter the Arctic Ocean through the Bering Strait in the summer and further ice loss. And Tredenberg published and admitted to that too. And NSIDC concluded, many questions still remain to be answered, but these changes in ocean circulation may be important keys to understanding the observed loss of Arctic sea ice. The author of this assessment was never heard from again and replaced by someone who didn't like that particular stance on that issue. You're going to affect our funding. Now, you're going to find much more detail on these rebuttals, and Tom was a co-author on series. I think we had 12 or 13 alarmist claims that we rebutted. Tom worked on sea level with Morner, and we had hurricanes that I worked with Neil Frank and Roy Spencer. David Legate's on droughts and floods, and very good co-authors on each one of those. We maintain them. We update these alarmist claim rebuttals each season as new data comes in. And you can find it on IceCap. I'm going to keep it as an evergreen in the right column. If you go to icecap.us, it's called the political climate. And I update whatever needs to be updated as the seasons pass. As was said earlier, we've done a number of, as Randy said, a number of legal briefs, and we've covered that the endangerment finding and why it needs to be, eliminated, and all the data that supports the bad science that it's based on. And thank you very much.
In the chat area, I noted that when you're looking at tornadoes, we have many, many more and better competent radars than we had 30, 40 years ago. So we're actually, even though tornadoes are still in fact declining, we missed lots of tornadoes in earlier years, and they're still dropping.
You're absolutely right. We also didn't have spotters. We didn't have NexRad. We didn't have everybody with a camera on their phone that can take a picture of a funnel cloud or touching the ground. And so it's amazing that we have a decline, as you said.
Joe, you and I have talked about the various data sets that are used to calibrate models and whatever. And if you understand that the TRCS has used the head-croup 4 data, okay, they chose that even though they know there are problems with it. Can you compare that data set with the NASA and NOAA data?
I would regard, and I think most people would, the Hadley data set as the better of them. And but the satellite data and used to be the balloon data, although one by one the balloon data sets get changed. But Roy and John's data is the best for the troposphere. The Hadley is probably the other one I would use.
I complained about the HADCRUT 3 to 4 transition. And the reason I complained is that HADCRUT 4 added about 600 stations in northern Russia in little urban heat islands. And the effect is it translated the entire temperature data set upward so they could claim that this is the warmest year ever. Hadcut 3 did not do that. Hal actually put it in his paper, and yet I do agree that the Hadcut 4 is the best data set. It's better than GIS because GIS interpolates between those heat islands and basically makes large swaths of cold land appear warmer because they're averaging the data sets between the urban heat islands. So
they also claim that they have the best Arctic data. There's no Arctic data. The penguins, I mean, there's no penguins up there. The polar bears report late or what, you know?
Somebody wants to know, how can you figure out what's true and what's not in terms of data sets?
It's a good question. You know, we look at how it's changed over time, and like I showed you the Maine temperature. I really liked that original data set that Tom Carl said, and he actually did a paper defending the need to be very careful with urban areas. He said, you know, if we don't adjust for urbanization, we're going to have a 7-degree warming in 100 years. That's not real. So he was on the right track before that, and it fit perfectly the cycles in the ocean and the sun that we think are the real drivers for the cycle. But you know, after they remove that, you know, nothing works anymore. So they keep changing things on us.
A couple of years ago, I went to Reykjavik, Iceland, and I was verbally attacked by an Icelandic meteorologist who said, "How dare you change the record of our temperature data set?" Because we had pushed down the 30s and risen the newer ones. And he was screaming at me. The problem is the data is collected at an American air base, which is 15 miles away from downtown Reykjavik, and they control the data. The Icelanders have no choice but to accept what the air base did. And once they pushed down the 30s and rose the reefs and stuff, they were stuck with it. And I took that heat. I told them it had nothing to do with it. Quite an adventure.
Joe, this is Greg Goodnight. I noticed in the 2019 NASA data set, the 1930s were cooled again. And my understanding is that there was a so-called time of day adjustment where in the 30s, what you're supposed to do is take 2 temperatures a day, and what they presumed is that the reason that the temperatures were hot is because they were only taking the one temperature, the hotter temperature, the later in the day temperature. Do I have that right, or do you have any background on that you could share with me?
Well, they'll claim that was one of the adjustments that they used, but it's a very inconvenient data set because you see all those records. All the heat records were set back in the 1930s, and it's an inconvenient data point. They would like to see you know, it go away, and they've gradually been pushing it in that direction, in one way or the other. And TOPS is one of those adjustments. And
do you think it was justified?
There's probably, you know, for some stations, probably. I've asked that of people who work with those data sets more than I do, not government people, but and they say, well, not to the degree that they give it, you know, credence.
Yeah,
it's
probably not.
Right.
Berkeley Earth does a lot of adjustments to the data set. Would you comment on their data set? Do you think the adjustments are justified and accurate?
I don't follow them. I tend not to trust anybody at this point. You know, I still use the satellite data mostly, and short term, and I don't like the changes that they made to USHCN. There's a climate reference network. Is the only data I would like to see used, and they're kind of hiding it. This was an idea that John Christie had. He said, okay, if we're having problems with sighting, and that was one of the big issues, right? Where stations were, in urban areas or near runways, or and were subject to heating and not meeting the criteria set for observations by NOAA. He said, let's establish a network of stations in meeting the ideal location, away from trees, no concrete and track that data. If you track that data since it started in 2003 or 4, it's flat. There's been no trend since that time, in that time period. But we can't go beyond that. I wish we had, old data. I might want to take the original USHCN and then tack on the CRN, Climate Reference Network data at the end for the US. That's not going to help with the mess that they created for the global. But that might be, the best solution if I was to do something on trends for the United States.
Yeah.
And it becomes real hard for us that, we're trying to do forecasts, seasonal forecasts. And we use the past to forecast the future. It's hard to compare, current to the past when they keep changing the past, Thomas.
Yeah.
Tom
Okay.
Weissmuller does forecasts long range, and you got to deal with that too, Tom, right?
Yeah. Joe, I think there are a couple of ways that these guys can get at some of the data, but I think Tony Heller's website is helpful. Okay. So look, Tony's analyzed some of the data. So I think if you can provide the link to Tony's website, we'll do that to everybody. So the animations that you saw
right now,
and so Tony has done a good job. He had a nom de plume called Steve Goddard, but he was outed, and he finally showed up at meetings, so we figured out it was really Tony Heller. He does a nice job. He's been in Australia. He's helped a lot of people figure out the games that have been played. Now, Joe also did something for us. He pulled apart that hurricane data. So we have land strikes for Texas, every state along the Gulf Coast, Texas, Louisiana, Mississippi, Alabama, and Florida. So it's very useful. But we have an extraction of the Texas data because people say, well, we have more hurricanes here. I said, no. In fact, if someone was standing in the way of that hurricane in 1900 in Galveston, it had a different feel. But the idea is Joe spent a lot of time trying to extract stuff that we can use. Like I said earlier, he's filed a lot of comments. His science comments have been filed for EPA and lawsuits. So it's credible, useful, and he's always out there. But his website is very useful in terms of a backup. So hopefully we can deploy some of his good work. Now, so we're at that point. Thanks very much, Joe. And
I have a question.
Yes, sir.
Yeah, Frank Jamerson here. Joe, I'm familiar with a lot of your slides, and you talk about not having enough stations in the past. So I'm wondering, do we really have any data that we could put together and say, by God, this is the final word on the global temperature? Because what you're telling us is that there aren't many stations in the lower part of the hemisphere, and only recently we put in the buoys. So how can we really accurately describe the global temperature for the last 100 years when we have so much variability in the sources of the data?
Tom, do you want to have anything to say about that?
well,
Tom
keep
Weissmuller?
in mind, we have the Argo buoys all over the world. They are very, very accurate, and they cover both hemispheres, northern and southern hemisphere. So I would tend to rely on data that the buoys supply because they also supply temperature data. Now, by the way, Anthony Watts, another one of our meteorological colleagues, has done magnificent work on sighting of temperature, the screens that the Weather Service uses. And he's pointed out places where jet engine exhaust can heat one of the Stevenson screens, or where there's one placed and they put a building next to it and an air conditioner pumps heat out of that building and hits that Stevenson screen. And NOAA, to its credit, has slowly removed some of them, but too slowly in my view. And Anthony has pointed out 100 that need to be removed. And I wish him Godspeed. He's doing yeoman's work in doing that.
Okay, what I'm hearing is that the buoy data is the best data we have. Therefore, do we have a plot of buoy data alone to show whether, since it's been started in 2000, as I recall, so that for the past 20 years, do we have any trend showing in the buoy data?
Yes, it's flat until they adjusted that buoy data for the ship intake data. It was flat, not exactly flat, but there was
Okay.
no trend.
All right, well, let's use that as a gold standard. Why don't we publish that and have it in the New York Times tomorrow, Joe?
And
I'm
the Climate
serious.
Reference Network, the Climate Reference Network is being ignored too. It's not showing what they wanted.
Excuse me, we have one last question. One last question from Jim Peacock.
Yeah, Joe, thanks a lot for the presentation, and Tom, you too. My question is, it looks like when human beings are trying to measure temperature, that's the absolute worst thing that they know how to do. But my idea, it would be like the sea boys, they pump out data all the time and they're normally not bothered, as also the satellite data. Is there anything wrong with using just satellite data and sea buoys to determine what the temperature of the Earth is?
No, actually,
Well, the problem is that people are corrupting that data with like the ocean ship intake. And corrupted data is like taking arsenic and oatmeal and saying, well, we're only going to put arsenic in half of the data and you'll be okay if you eat it. Corrupted data is
I'm
corrupt.
talking about
You
just
cannot rely on it.
taking the raw data as is, and what's the ship intake temperature got to do with the buoy? Let's go with the buoy temperature.
Right, exactly.
yes, the buoy temperatures alone,
Say
not
again?
the adjusted buoy temperature. Yes, the buoy temperatures by
Yeah.
themselves were giving us the better, accurate data, but that they have adjusted that. Now, can you find the unadjusted data anymore? We did see where Ali Humlin on Climate for You was able to plot the unadjusted, but the good stuff gradually disappears.
Well,
Right,
yeah,
Tom?
that's because these guys need to make a living, so they lose their jobs if we went to satellites and buoys. Anyway, I just thought that would remove the human error element out of it.
Yep. That's satellite going back to 79, and the buoy data is from from 2000, and the most reliable.
Yeah, thank you.